In this video we're going to simplify radical expressions. First one we'll take is square root of 36, and that's simply 6. 36 is a perfect square. 6 times 6 is 36. Another one, we'll try square root of 196. And in this case, that's the same as the square root of 14 times 14. 196 is a perfect square, so the answer is 14. Another one, negative square root of 49. Because the negative sign is outside of the radical sign, we don't have a problem with that. So we can say square root of 49 is 7, and the negative is outside, so we have minus 7. Another one, minus the square root of 225. Again, 225 is a perfect square. 15 times 15 is 225. And the negative sign is outside of the square root, so we're okay. So it's minus 15. Now, another example, square root of minus 225. Now in this case the negative is inside, and you can't take the square root of a negative sign without getting an imaginary number. So for the purposes of manipulating these expressions, for this we would just say no solution. If we were working with complex numbers, what we would have here would be square root of 225 is 15, and the square root of negative 1 we call I, an imaginary number. So it would be 15I. Okay, a few more numbers. If we have the square root of 6 times the square root of 6, the product property says we can put them together. Square root of 6 times 6. And what number multiplied by itself can give you this number? Well, 6 can. So the answer to that is 6. Or another way to look at it, 6 times 6 is the square root of 36. 36 is a perfect square. The square root of 36 is 6. Alright, another example, we'll take 4 times the square root of 2 times the square root of 2. Well, we can combine these two. We have 4 times the square root of 2 times 2. And this is similar to the situation up here. It's 4 times the square root of 4. 4 is a perfect square. So the square root of 4 is 2. So we have 4 times 2, which is 8. Or another way to look at it, number times itself equals this. That number is 2. So a 2 comes outside, and we end up with a 2 times 4, or an 8. Let's try a couple with the quotient property. If we have the square root of 11 over 16. That's the same as the square root of 11 over the square root of 16. 16 is a perfect square, so it becomes a 4. So we end up with square root of 11 over 4. 11 is not a perfect square, and it's a prime number. It can't be factored. So that's as far as we can take it. To go any further, we'd have to use a calculator and end up with a decimal value. Some more examples. Well, let's take square root of 9 over square root of 9 over 3. So we can actually divide this and be done with it. So 3 goes into 9, so it ends up just a square root of 3. And you can't reduce that any lower. Let's see, some more. Three times the square root of 16 over 81. See where we can go with that. Well, 16 is a perfect square and 81 is a perfect square, so I guess what I'm going to need to do is take the square root of 16 and separate it over the square root of 81. Square root of 16 is 4, square root of 81 is 9, so we have 3 times 4 over 9. And 3 is common to 3 and to 9, so we end up with 4/3. So, there you have it.